Okay, all right. So like last week, we're gonna get started with SQLite 3. Let me play this real quick. On how we represent relations, right, within databases. So again, the three types of relationships that exist within databases are one-to-one, one-to-many, and many-to-many. So let's boot up SQLite 3, just like we did last week. And now we're in the SQLite 3 shell. Cool. So again, the way to create a one-to-one relationship is to create two different tables that have, one-to-one relationships, right? So the first one we're going to make, and you don't have to copy this. This is like a SQL demonstration on like how you're going to be representing these kind of relationships. But yeah, the first one is going to be a user table, right? It's going to have an ID, which is an integer, primary key, auto increment. Name is text not null. And I see a few people copying, so I'm going to let y'all do that. But you don't have to copy. You're not going to be using this for your assignment. It's just for demonstration purposes. So that is the first table we're going to make. The second one is the second table that is going to have a one-to-one relationship with users with, right? The second one, this create table, let's call it profile, which is going to have also an ID. It's going to have a net ID, right? So this is the example given in lecture. And then it's going to have a user ID. So note this unique keyword. We didn't have this in the one-to-many relationship. But the reason why we have a unique keyword is because each profile can only be ever associated to one user, right? So we want this user ID to be unique across the table. And then we'll specify that this user ID field is a foreign key, right? By passing in the field name there. And then the keyword reference is the name of the table, which is user, and then the name of the field, which is ID within the users table, which is up here. Oops, up here. All right, so now if I do dot tables, we can see that we have two tables, the profile table and the user table. Does everyone follow so far? Cool. And right, so now let's start inserting values into each of these tables. I'll first start with the user table. I'll insert into the user table, name, the field, right? The field we want to enter into, values, and then Shungo. I'll enter another user into the table, Jessica. And now if we select all from users, we can see that we have two entries, myself and Jessica with our respective IDs. So hopefully that's straightforward so far. And now let's actually start inserting data into our profile table. So we'll do insert into profile, and the fields we want to enter into, which will be net ID and user ID. Net ID, oops, I just called it net ID, and user underscore ID values. Well, I guess this isn't really a test of your backend knowledge, but it doesn't even remember my net ID. No, that's fine. Okay, SN685. All right, what would be the user ID for this entry right here? 1, correct. Thank you for the singular finger that went up. Okay, insert into profile. Net ID, user ID, values. Anyone Jessica's? No? All right, that's fine. And 2, right? So now we have entries in our user table and in our profile table. And I guess I could have like swapped up the IDs of the profile table and the user ID it's associated to, but that doesn't really matter. The point is, this entry right here in the profile table, right, has an ID of SN685, and the user that it's associated to is a user with ID 1, right? This entry right here, the ID of JZS27, is associated to the user with user ID 2. Yeah. So now if like, let's say I want to add like another person, in our profile table. And that's Gonzalez net ID. That's our backend lead. Let's say I want to associate his net ID to like my user, right? My user profile. Well, we specified up here that the foreign key has to be unique, right? So this isn't, SQL isn't going to let me do this, right? Stepping unique constraint. So that's not going to happen. Again, the benefit of using a database as opposed to a Python dictionary, if this wasn't clear enough. Cool. So that's a one-to-one. I noticed there was a question earlier that was very good about why we use one-to-one relationships in the first place. Yeah, I don't know if that was like fully like understood. So just to, like re-explain. Let's say we want to be creating an app for like booking rooms, right? And let's say one of the information about this room booking is like when the room is booked from, when it's booked to, you know, like what time, how many people are going to attend, like all that kind of thing. Maybe like the number of attendees is like specific to that event, right? But like when it starts, when it ends, all that like detail can maybe be like wrapped into a table called like timestamp, for example. So usually you would use a one-to-one relationship for something that, you know, you wouldn't traditionally want to represent in like one variable in like Python, for example. You would want to represent as an object, right? So like, as opposed to like, you know, having the time start and time end, you would have like a time frame object, which would then be a different table, for example. So it's kind of like to like modular, make things modular and like separate things out. That way it's like understandable. But yeah, that was a great question from earlier that I wanted to make sure everyone understands. Cool. So that was one-to-one. Let's get into one-to-many. So, right, there's several types of one-to-many relationships. I think the one mentioned in lecture was post. So let's do that one. So I'm going to create a new table called post. It'll have an ID of integer primary key auto increment. And it looks like no one's copying anymore. Am I typing too fast? Sorry. The description will be a text not null. The user ID, right? The person who actually posted this post will also be an integer. But this time, I mean, it has to be not null because we want to know like who actually posted this, made this post, right? But this time we don't have the unique keyword because, right, a post doesn't have to be like unique to a user. Like a singular user can make multiple posts. So that's why this field isn't unique. And likewise, we'll mention specify that this user ID field is a foreign key. Foreign key user ID references user ID. And the syntax here is just references and then the table name and then the field within the table that we're trying to reference. Cool. So now if we do dot tables, we have a post table, a profile table, and a user table. Also, hopefully this is like visible in the back. Please let me know in the future if it's not. I can always change that very easily. Okay, so let's start inserting data into our post table. Description, user ID, values. All right, what is something that Jessica would say? I don't know. I love Max flatbreads.
They're so good.
That is something she would say. Okay, she has the user ID of 2, so let's do that. And then, well, I guess I can carry on the example from last semester. My co-instructor gave like demo 3 last year, and she wrote, well, in place of Jessica was her name, but Jessica is such a better course instructor than me. So that can be my post, user ID 1.
Oh, thanks, Shingo.
Insert into insert into user ID values. Let's make another post for myself. I don't know. I love baseball. So notice here, like I made 2 posts for myself, right? Both with the user ID 1, but because the unique constraint wasn't there, I'm able to make those 2 posts. Cool. So it's actually very cool. Select all from post, right? Oops. Post. And you can see here that we have 3 posts, right? 1 being from Jessica and 2 being from me. And kind of like combining the concepts we learned from last week, if we do like select all from post where user ID equals 1, for example, we can see the post that I specifically made, right? So this is why one-to-many relationships are very useful. And you can see how like, I think homework 1 was like posts and comments, right? That would be a one-to-many relationship. Yeah, sorry for not teaching you that before homework 1, I guess. Okay, does that make sense so far? One-to-one, one-to-many. All right, let's get to many-to-many. So this is the one that's gonna start tripping people up, I think. It's the one that tripped me up at least. So let's create a table called feed. Now this will be the join table that, or sorry. We'll first create a table called hashtag with the ID integer primary key auto increment and then the name of the hashtag. Okay. So this is like on Instagram, right? Like a singular post can have multiple hashtags, and the same hashtag can be used by multiple posts, right? So this would be a many-to-many relationship. So using this hashtag table that we just created, we can now create a join table or an association table that kind of like combines the two together. So we'll call that table feed, right? ID as well as usual, integer primary key auto increment. Post ID integer not null. Hashtag ID integer not null, right? So this is relating the two tables. We have foreign key, post ID references, post ID, and foreign key hashtag ID, hashtag ID. Cool. So we have a post table, right, with IDs for each post and a hashtag table with IDs for each hashtag. Okay. So now we can start making hashtags. So let's start with that, right? Let's start by making hashtags and then later explore how we can actually relate the two hashtags and posts. So we'll insert into hashtag name, and let's call this one like food, hashtag food. And then insert into hashtag name, hashtag cool or something. Sorry, my hashtags are very lame. I'm not a grammar. Select star from hashtag. All right, so we have two hashtags, food and cool. Okay. So let's like first display both posts and hashtags, right? So we have these 3 posts and these 2 hashtags, right? And we can assign multiple hashtags to multiple posts and vice versa. So the way we're going to do that is by inserting into this feed table, right? This feed table has 3 fields. One ID is just to uniquely identify each row in the table. This one isn't super important. The other 2 that are very important are the post ID and the hashtag ID, right? So it's kind of like pairs that of relationships. So let's insert into feed, right? And the 2 fields we'll be entering into are the post ID and the hashtag ID. Okay. So, right. So what post would like be appropriate for the food hashtag? Probably the first one, right? Maybe the third one, but if we're adding the food hashtag to the first post, what would the 2 values be here? Any ideas? Right, the food hashtag has ID 1. Cool has 2. Yeah, 1 and 1, correct. Thank you. Perfect. Okay. All right, let's try another one. Post ID, hashtag ID. Let's add the cool one to the second. Actually, let's add the cool one to the third post. All right, that would just be 2 and 3. And you can add the cool one to like the second one too. Maybe the first one as well. Okay. So now if we do select all from feed. Yeah. Oh, you're right. Sorry. Oops. Um, let's not delete. No, I can delete. Okay. What was it? 3 and 2? Right? Okay. Thank you. 3 and 2 and 1 and 2, right? Yeah. Okay. Thank you. Thank you. All right. So this looks very cryptic. I have no idea what's going on. So how are we gonna figure this out? So this is now we start getting into the intricacies of SQL that's not gonna be like within the scope of the class. But as you can tell, database design is pretty cool. And if you learn SQL, eventually you can do cool stuff like this. And this is nothing like what's going to be tested for this course. So you don't need to like memorize this at all, but just some cool things I want to show off, I guess. So select post.description, hashtag.name from feed inner join post on feed.post ID equals post dot hashtag on tag ID equals hashtag dot ID. Okay, that was a lot of work for nothing. Oh, I am. Okay, I didn't need that closing bracket, I think. Post feed inner join post on inner join hashtag. Yeah. Okay, so that's much better, right? We can tell what post or like what the description of the post is and like what the name of the hashtag is. And we can even do cooler things like select, oh god, this is gonna be even longer. User.name, post.description, hashtag.name from feed, inner join posts, inner join user post.user ID equals user.id. On feed.post ID equals post.id. Hashtag hashtag.id. So now we can even tell the user of like the poster, right? So again, SQL intricacies, but clearly the relationship is defined, right? Otherwise, we won't be able to do something like this. Oh, was there a question or? Okay, yeah. So yeah, that's basically it for the SQL portion. I hope you found that entertaining, me messing up at the end as well. But yeah, I think that's basically it that we can cover with today's time, but hopefully that was enjoyable. One-to-one, one-to-many, and many-to-many. Any questions before we move on to Kahoot? Yes.
Where did you learn how to do all that?
This iPad. No, I'm kidding. No. There's like lessons you can take on SQL. There's also like a database course like at Cornell, CS 4320, that you could take after this course, I guess, if you're interested. But yeah, I mean, it's not like it's just a bunch of like SQL commands kind of like compounded into one big thing. So yeah, you'll be able to understand if you look up what each of these keywords mean. Also, one thing I want to mention before we go into the Kahoot is that SQL can be typed in lowercase, but please don't do this. If you do this, you'll get style points off for the programming assignments because SQL, like, it's hard to tell, right, from this, like what the SQL keywords are, which is why we've been intentionally writing them in uppercase. But yeah, so like if you are curious after lecture, just look up everything I like typed in uppercase, and you'll probably be able to understand them. Any questions? Cool. Okay. So as usual, the demo code, the starter code is going to be in the pre-class studios. Again, Gitbook's kind of annoying, so you might have to refresh it for this to like be the updated version. But as long as you see that if you open it, the app.py is on port 8000, then you should be fine. I hope you all know that demo isn't a place where you should expect yourself to be able to copy everything down. Again, I do have to get through everything, so hopefully it's a bit understandable if I don't like stop at every point for you guys to copy. But you guys can slow me down if I'm actually going too fast. So hopefully that makes sense. Cool. So let's open this this folder on our VS Code, right? Our text editor. So I have it as usual, stored in my demo3 folder. So opening my terminal, right? I'm going to cd into appdev, the backend course, and then demo3, and then I have my source folder here. And I'll code dot and open the source folder in VS Code. So this is just routinely things. By now, I hope y'all are comfortable with that. But this is the completed demo2 code. So we're going to be starting off with this. If you recall, demo 1 and demo 2 were making a to-do list kind of app, right? So each app we made from demo 1 and demo 2 had like tasks, right? But this time, right, this week we learned about relationships, right? One-to-one, one-to-many, and many-to-many. So we'll be implementing one type of relationship in today's demo, which will be one-to-many. And one-to-many will be the many part of this relationship is going to be subtasks. So we have tasks, like main things to do, and then subtasks that kind of branch off of it. Cool. Okay, so again, this should be very familiar. This is just demo2 code, right? Same with app.py. I guess one thing I'll add is I see a lot of people getting issues with like creating like this function specifically, because it throws an error that this table already exists. So the way we can work around this is by typing if not exists after create table. This way, by doing this, it's not actually going to create the table if the task table already exists. So you can add that to the starter code, or you can just call the delete task table function right above the create task function, create task table function, but that is up to you. Cool. So again, all this is demo2 code. Let's look at app.py. So app.py is going to be a bit different. Actually, let me disable this. So app.py is going to be a little different. We have these two types of generalized responses, right? We have a success response and a failure response. All this is going to do is make our lives easier with returning like a response body, right? So every time we have a successful response, we just want to call the successful response function. Every time we have a failure response, we're just going to call the other function. For those of you who are not familiar with Python, this syntax right here means that code is going to be a second parameter, but it's optional. And if you don't actually pass in a value, it'll just default to 200. Otherwise, it'll override it with whatever value you pass in. So if you create something successfully, you would pass in a body and a code. But if you're just like deleting something, right, you would just pass in a body and the code will just default to 200. So that's what these two do. Yeah. Any questions so far? Okay. Then I'm going to open my terminal. And as usual, right, I'll do Python 3 and create a virtual environment. I will activate the virtual environment and pip3 install -r requirements.txt. So let me scroll up for those of you who weren't able to copy that. But yes, so this should be the virtual environment setup with all our requirements installed. So should be routinely from lecture 1 from by now. How much can I shrink this? Maybe that much. Is the code visible in the back? Hopefully it is. Okay. Yeah. So I just created a virtual environment, activate it, and install everything. Cool. So let's start getting into the crux of today's demo. So again, the first thing we're going to be doing, or the thing we're going to be doing today, is implementing subtasks, right? That has a one-to-many relationship with tasks. So the way we're going to do that is first, right? we have to note that when we have a relationship between like two entities that we want to model, those two entities are going to be two separate tables, right? So the task table is going to be its own table, and then the subtask table is going to be its own table as well. So we're going to create a function called create subtask table, in very similar vein of create task table. And then self.con.execute, right? Multi-line string, and I'll do create table if not exists subtask. Oops. Okay. So I created a table if not exists subtask with the field ID, which is an integer, primary key auto increment. It's gonna have a description, text not null. So this is very similar to the task table. Done, which is a integer. Oh no. So this can be a Boolean. Let's just change these both to Boolean. And the reason why it was an integer initially in the starter code is because Booleans in SQLite are just stored as integers, as zeros and ones. So it doesn't matter to SQLite if we specify as a Boolean or an integer, but yeah, let's just call it Boolean for since it makes more sense to us. Okay, so what is the last field that is missing here in a subtask table if we're trying to relate it to a task table? Does anyone remember what the the foreign key, right? So we'll call the foreign key task ID, which will be an integer, right? Because this is the type of an ID, the data type of an ID. And then the way we specify that this task ID is a foreign key, right, is by this syntax, right? Foreign key, and then in brackets, the name of the field, references, and then the name of the table, which is task, and the name of the field, which is ID. Also, I'm pretty sure, yeah, so you might need to change this to task, like the singular version. Yeah, sorry for the hiccups in the starter code, but yeah. And don't forget the semicolon. So yeah, we just created a subtask table that has the fields ID, description, done, task ID. And the task ID is a foreign key pointing to the task that it's associated to, right? So that's a create subtask table function. And then once we've done that, let's go up to our init of our database driver. And just like we created the task table here, we'll do self.create subtask table. So now when we initialize this app, right, the first thing it does is create a task table and a subtask table. And the subtask table, we right, just represented it so that it links back to the task table. Okay. Everything else, everything makes sense so far? Yeah, okay, great. Then let's make the next function. So we have a task or subtask table that we want to work with, right? Okay. Yeah, let's make the function for inserting into a task subtask table. Insert subtask, and then it'll have a self, right? Description, done, and task ID. And then, oh, and let's write some documentation as well, as usual. Oops. Using SQL. Creates a subtask. What do they call it up here? Subtask table. And then down here, we'll do using SQL inserts a subtask, or what do they call it up here? Sorry. Adds a new subtask into the subtask table. So I'm just trying to make things consistent. And from here, we're going to, right, make a SQL query to actually add the subtask into the subtask table. So the way we do that, right, is very similar to last week as well. Cursor equals self.con.execute. Insert into subtask, and then description done task ID values question mark question mark question mark. Try this real quick. And the values we actually want to pass into these question marks are what's just passed into the parameters, right? So that's description, done, and task ID. Okay. And once we're done with this, we want to actually commit the changes, right? So this is like saving the changes that we made to the database. So that would be self.con.commit. And then, like Jessica mentioned last time, when we actually use an insert query in SQLite 3 in Python code, right? What's actually returned to this cursor is like this object that kind of represents your newly created entry. And we want to retrieve the last row's ID, right? This way we can actually use this ID and retrieve the subtask that we just created. Okay, so again, the next step is to actually retrieve the subtask task that we just created, right? So we'll do get subtask by ID. ID using SQL gets a subtask by its ID. And in very similar vein, cursor equals self.con.execute. And you can probably start seeing the pattern here. All SQL queries go into the self.con.execute in SQLite 3. So yeah, what would this query be? Any guesses? Retrieving subtask by their ID. Yeah. Oh, actually, you can go. Sense. Yeah, amazing. That's perfect. Yeah, so we want to select every entry, which is only going to be one, right? From subtask, where the ID is, right, that the ID that we passed in, like you mentioned. So this is going to be a tuple, and the way we represent single element tuples in Python is with ID followed by a comma, right? Don't forget this comma. It's gonna mess up a lot of people, but yes, that is how you represent a single element tuple in Python. Okay. So when we actually sorry, when we make a select query in SQL, right, this cursor object is something we can iterate through, right? So whether it be getting a subtask by its ID or just getting all subtasks in general, we'll be looping through it by doing for row in cursor. And we did this last week as well. For row in cursor, and again, there's only one, right, row with this ID, so we can just return the first one that we see. You have an ID of ID, a description of row 1, a done of row 2, and a task ID of row element, the third element. And this can also be just changed to row 0 if the consistency matters to you. That doesn't really matter. And if this return statement isn't hit, that means that we didn't actually find anything that has the ID that we specified, right? So in that case, we'll just return none. Okay. Okay. So everyone good? Can I move on? Cool. Okay. So let's go to app.py now. And let's implement a task subtask endpoint. So we can do subtask endpoints. Okay, so the first one is going to be creating the subtask that we just made, right? So app.route tasks int task ID subtasks methods. So the reason why we have task ID specified is because we want to make a subtask for a specific task, right? So we need the task ID of the task that we're trying to make the subtask for. Oh my God, how many times am I going to say task today? So we'll create a function called create subtask and pass in the task ID. And document it. Endpoint for creating a subtask for task with ID. For task with ID. Okay, then usual routine body equals requests, or no, body equals JSON.loads request.data. Description equals body.get description. And then we'll do task equals db.get task by ID. Right, and this is already implemented for us. We just have to pass in the ID of the subtask. Oh, and one thing that's really cool is I don't know which extension it is. I think it's just Python. But if you write documentation like we are here, you can see that, right? The documentation just like shows up on my text editor. So also important why you would want to write documentation. And it also tells you what like your input should be. It should be like an ID, right? So the ID will be task ID. And if this task is none, that means that the task wasn't found. So we'll just return, and we'll actually use our generalized return functions that we talked about earlier. Failure response, right? So again, the two parameters we need is the message of the failure and the code. The message is task not found, and the code is by default 404. So we don't actually have to specify that as 404, even though you could if you really wanted to. But that's not necessary. So this will just return a 404 error on its own. Okay. So then the next step is, right, at this point, we know that the task was found, right? So we can actually create a subtask for that task. So then we will just call the db dot create, wait, was it insert? Insert subtask. Insert subtask into our table. And the three fields we need are description, done, and task ID. So we'll just pass those in, description, done, and task ID. Oh, and done is not a variable we specified here. So as per usual, let's just assume that a task that we newly created is just false by default. Okay, and if I hover my cursor over insert subtask, you can see my parameters as well as my return type, right? So my return type is either going to be an integer or none, and that's because in db.py we either return oh, hang on, sorry, this is the wrong function. It just returns the last row ID. So this would be the subtask ID. Sorry for the confusion. But then from here, we can do subtask equals db.get subtask by ID and pass in this subtask ID. And here we can see that the return type is either a dictionary or none, right? And the none comes from if the subtask wasn't found. So if the subtask was found, it'll return the dictionary of the subtask. If it wasn't, it will return none. So if subtask is none, then we'll return a failure response. Could not create subtask for whatever reason. And assuming our logic is correct, right, the error here would be caused by the client. Like the client messed something up. So the code would be just be 400. 404 is for something that wasn't found. 400 is if it's the client's fault. It'll be the 500s if it's the server's fault, but that's not like the server is us, but we're not doing anything wrong here. So we'll just blame the client, I guess. And then if it was found, then we'll just return the subtask. Oh, sorry. Let's put this in a success response as well. Success response, subtask, and it's a new creation, so it would be 201. And I spelled that wrong. Success response. So, okay, hopefully that made sense. So we're retrieving the description, and in the URL, we pass in the task ID, right? Then we'll retrieve the task. If it's not found, it'll throw an error. If it was found, it'll create the subtask and return the subtask to us. So now that we have that logic implemented, let's oh gosh. Okay, let's actually run this code. So start this app. So as usual, Python 3 app.py. And we'll go to Postman, create a new collection called demo3, make a new request. And let's first do get all tasks. And you don't have to copy this part either. I'm just trying to create task table. Shoot, that's annoying. Okay, so all these tables are called tasks. So it might actually be a hassle to replace all of these with task. So I'm just gonna rename this back to tasks. It's kind of annoying, sorry. And then in the foreign key field, we also have to change this back to tasks. Okay. So let's restart this server. Let's try that again. Okay, so now it gives us all the tasks that we have. We can duplicate this and call insert task. Make this into a post request, and the body would be body would be description and done. No, not done. Done is just false by default. So the description is hang on. What is something I have to do? I don't know. Give demo3. So that gave us a success response, right? So now we have a task called give demo3 in our task table. And let's add some subtasks to this, right? So let's duplicate this endpoint and call this insert subtask instead. And we'll pass in the task ID in the URL, followed by subtasks. Oops. All right, that's the endpoint we just created, subtask. It's a post request, and we pass in the details of our subtask. So give demo3, I don't know, prepare starter code for demo3. So let's make a post request here. And you can see that the endpoint at least successfully ran. So we need a way to actually check if the we need a way to actually check if the subtasks are actually associated to the task with task ID 1, right? So the way we're going to do that is by making a new function, tasks, task ID, subtasks, get subtasks of task. So this is going to be a function for retrieving all the subtasks for a given task, right? So again, the comment is going to be endpoint for getting all subtasks for task, but with so this is actually not going to be that difficult. We can copy and paste the code here. So if the task wasn't found, then we'll return a failure response being, or saying that the task wasn't found. But otherwise, we will return a success response of a function we haven't implemented yet. But subtasks is like a list of tasks, right? Or a list of subtasks. So we'll do db.get subtasks of task. So same as the function name here, and we'll pass in the task ID. So we haven't implemented this, so let's go ahead and do that. We want to retrieve all subtasks given a task ID. Okay. So do def get subtasks of task, and we're given a task ID. Using SQL, get all subtasks given task ID. And this function right here, right? Select cursor equals self.con.execute, and we'll execute another SQL query. Select all from subtask where the task ID equals some value, and that value is a task ID we just passed in. Right, so this is how the relationship is made, right? Each subtask has a task ID associated to it, and we can just query by the subtask, or we can just query by the task ID. Oh, oops, I forgot to pass in self here. And then, once we have a cursor containing all the subtasks, given the task ID, right? We want to make an output object. So the output object, we can just call subtasks, initialize it to be an empty list, and we'll loop through every row in this cursor object that we attained. So for row in cursor, right? We'll do subtasks dot append. And because this is a list, right? We're appending something into the list. And we can append the subtask individually. So the ID, right, is just row 0. The description is row 1. Done is row 2. And task ID is row 3. And depending on how, like, if you actually want to, get the sub or task ID back, you can just get rid of this. But that depends on your API specs, right? The API design, and that's a bit out of the scope of the class, but you can start seeing the flexibility of these functions. You can just customize the return to be whatever you want it to be. Okay, so now we have a list of subtasks, right? Initialized as an empty list. And so we can just return that object at the end after we're done looping through every row in the cursor. Okay. Seems like people are still copying. Another thing to note is that this function is only called with a valid task ID, because if you look in the endpoint, if the task wasn't found, it'll just return a failure response. So it'll never actually reach this line of code. So if it does reach this line of code, you can kind of assume that this task exists. So when you return the subtasks, it's okay that it's returning an empty list as opposed to none like we had earlier. So hopefully that makes sense. Okay, so let's test this, right? We have it saved, we have the server running, and we can duplicate this, get subtasks for given task ID. This is a get request, and we just have to hit the same endpoint that the post request hit. So we can get all the tasks, right? We still have our give demo 3 task. And earlier we inserted a subtask called like prepare starter code into the same task that we just created, the task ID 1. So if we pass in like an invalid task ID, right, we're just gonna get a task not found. If we pass in the correct task ID, we'll get the list of subtasks that is created for this task. And obviously, like if you create a new task, no, let's call this make PR for app dev. And make a new task, right? We have 2 tasks now, but the second task doesn't have any subtasks associated to it. So if I call get subtask given task ID on task ID 2, right, it'll just give us an empty list, which is exactly what we want, right? We don't want like an error response, even though there are no subtasks associated to it, but the task actually exists, so it's okay that it's an empty list. Okay. So that's basically the gist of this week's demo. Obviously there's like delete, edit, subtask, but that kind of follows a similar vein of editing and deleting like the tasks table. I guess one thing we can do before our Kahoot, which we'll probably end a bit earlier today, is when you get all tasks, right now it just returns the ID description and done, right? What if we want to actually see the subtasks that's associated to each of these tasks as well? If we want to do that, up in the get all tasks function, right? The reason why it's only returning the ID description and done here is because of this code, right? This line of code only returns those 3 fields. So let me make this a bit nicer to read. Okay. So yeah, this is just a little extra, but if we want to see the subtasks associated to this task as well, right? We can do a cool thing such as using the function that we just wrote down here. So you can do self dot get subtask of task and pass in the ID of the task, which is just row 0. So you can be clever with things like this. Again, this is just like things that would make your life easier when trying to match API specs, but we just created a function for like getting subtasks given a task, right? So might as well just use it. So now if we go to our get all tasks endpoint and test it in Postman, you can see that the subtask is returned to us as well. So we have ID 1, give demo 3, prepare starter code, make PR for app dev, and let's add another one. And edit demo 3. Sorry, my examples are very boring today. I didn't really come up with any before lecture, but yeah, you can see here that both subtasks are present. And this can be done just by like kind of cleverly using the functions that you wrote in your db.py. Obviously, you can use functions in db.py that you write in app.py as well. Okay, so that was one-to-many, and right, the only difference between one-to-many and one-to-one is having a unique keyword here. But otherwise, many-to-many is something we'll cover next week, or not next week, but like the week after fall break. So stay tuned for that. Any questions before I guess we wrap up demo today? I think relatively this was a straightforward demo. Hopefully a lot of it was copied. Okay. Well, I guess if we don't have any questions, we can just go ahead and get started with the Kahoot. Also, one thing I wanted to note with this app.py and db.py kind of structure, just as like general good coding practice, is app.py should do a lot of like your like business logic, right? So if let's say you're on PA2 and you're trying to do like the send money function, and you want to calculate like the new balances of like the sender and the receiver, that should happen in app.py. Calculations and other things shouldn't happen on db.py. Rather, db.py should be individual SQL queries that we like pick and choose to use in app.py. Yeah, so this will make your life easier if you kind of follow that paradigm. But besides that, I guess there's nothing else. So we can just get started with the Kahoot.